My dear IM student, again we are interacting for the second page of today's lecture, that is simple harmonic motion. You may say, I have read it in physics. What is the new in it? But again I say, when we go within and within, we learn something that in depth there are many things which we do not know, although we think that we know, which is the real fallacy in engineering in general. Let us try to start from the known thing, because our aim is to go from known to unknown, or in accordance with law of governing, from being to becoming. Let us start from the known. It says that there is a spring, mass m, mg, particle reaction is R, which is called the normal reaction. I am taking, there is no friction, and force x double, this is x. Therefore, forwarding force is nothing but mx double dot or d2x dt2. Now, spring force varies with the extension length x. Spring force Fx may be developed in power storage or Taylor storage, that is kx plus k1x square, in this way go on. We have got an elasticity, the same type of curve, load versus this curve goes on like this. I am restricting myself to the lower part, since I am taking essentially nature to the first order is simply linear in nature. Therefore, from K2 onward, I am deleting, though it gives you the nonlinear differential equation. I want to restrict myself in linear and see what happens. This moves in the opposite direction, therefore, sorry for the interruption. Therefore, mx double dot is in opposite direction. Therefore, minus, this is minus, this balanced by this, plus it will come here, plus kx equal to 0. How I got it? Just in the same way as I told in terms of previously. What is the previous model? mf is in this direction. Therefore, minus mf is in opposite direction. This is the direction of tension, which affects nothing but kx. Therefore, kx plus m d2x d22, you pronounce in this way, because d2 d22 is an operator. d2 dt2 of x, not d2x by dt square. This is totally wrong, because a into b is not equal to b into a. I then rub this, and I can easily understand this plus this gives us a 0. Understanding is, again, we are getting to get this wrong good thing, right, exactly the same thing out of a wrong process. Since when we draw, we won't grieve. This is mg is balanced by r. Had it been friction, this r will come into play. This part we don't take into account. Divide both sides by m, I get the same equation, d2x d22 plus omega square x equal to 0, where I again put omega as k by m whole to the power half. Now, if mass is one thing is very important, we don't want to see it from here, but it is important. You know the solution. I also know, you also know. And I did it previously in terms of theta, and I am doing it in terms of x instead of theta. Look at here. The answer is x equal to a cos omega t plus b sin omega t. Now two things are there. If m is small, then omega is large. Omega large means omega equal to 2 pi f. F is also large. I know from Planck's relation E equal to hf. Since f is large, therefore E is large. E means in one direction, you know equipartition theorem, half kt, Kb is Boltzmann constant. F is large means T is temperature is large. Again, this is equal to half mv square. Therefore, velocity of the particle is also large. Exactly the same principle is used in microwave oven. Have you ever thought that was simple SHM can lead to the basic concept of microwave oven, how microwave oven operates? Out of very simple example, although we know this thing for a long time. Again, if another thing is there, if m is very large, then omega small means frequencies, omega is small at that time, then time period is very large. These some things should be taken into account when you try to do something. Therefore, since it is a second order differential equation, there are two constant has to be given. As initial, depending on initial condition, it changes. If at t equal to 0, I take x equal to x0, and at t equal to t1, I take x equal to x2, then I can solve these two equations, or velocity may be given. The initial condition changes. The process of finding out A and B changes. But after all, I can find out A and B. Both of them are independent of time. Please note, independent of time, because I am coming to resonance case where both of them are time dependent, and you see it is not exactly simple harmonic. Now I simply rub it, understanding this is the SHM differential equation with omega is root of k by m. Answer is x equal to a cos omega t plus b sin omega t. Initial condition must be such, so two initial conditions are needed to find out A and B, and after finding out A and B, I can put A and B here. Important point to note, both of them are independent of time. If they are time dependent, whole thing will change, and that will come instantly now. With this, I stop known logic, known thing, as you know from first year, and go to something which you do not know. Let us take the case of forced oscillation. In forced oscillation, from externally, I am putting one force like this, sinusoidal force. This is forced oscillation comes here, and when a n square equal to omega square, whole thing changes then, and we'll do it later on. And we see how we do. In the same token, d square plus omega square, f1 d square plus omega square x equal to f cos mt. Now this is force F is amplitude per unit mass. Now it has two solutions, as you know. One is complementary function, other is particular integral. This part you already covered in differential equation. General solution equal to complementary function plus particular integral. Complementary part you know, as we have done, that is x equal to a cos omega t plus b sin omega t. If I find out particular integral, then and only then by adding both of them, I can get the general solution. That I try to do at this stage. Remembering this, I know this, and also know this. Therefore, I rub and try to find out particular integral. Particular integral, as you know, from x is f cos nt by d square plus omega square. And the theorem of differential equation is I have to replace d square by minus n square, because if it is cos ax by d square plus a square, answer is cos ax by minus a square plus a square. This is my differential equation answer, and that answer I am copying here, and if I do it with this formula, I at once get x, this is the particular integral, f cos nt by omega square minus n square. Therefore, general solution must be x equal to a cos omega t, I write again, b sin omega t plus f cos nt by omega square minus n square. Due to addition of this term, the amplitude must be increased. As you can easily understand, something is positive, cos minus theta is cos theta, therefore simply it increases the instant x. Since x increases, other things also increases. After all, it is again sinusoidal, it must be in the form, you can easily realize, a p cos omega t plus minus alpha. I can take cos common and put the result in this way. In the same token, by changing the values of the constant, you can get sine also. After all, sinusoidal nature. This thing totally changes when the resonance case comes. That is, when n equal to omega square, n equal to omega, the whole thing changes drastically. Convolutive function, whole thing drastically changes. I rub it and write it in a very rightly. This is the famous resonance case, when the soldier moves over a bridge, and if their natural frequency equal to if their forced frequency equal to the natural oscillation frequency of the bridge may collapse. That is always possible. At the time of designing, mechanical and civil engineers are extremely careful with respect to this thing, and they make natural frequency of the system so large that it cannot collide with the forced frequency. Now I go to again my calculus, my differential equation knowledge. Now question is like this: if this is d square plus a square, answer is x by 2d cos ax. I differentiated this today. I am writing the answer. I am not going to prove it, and I will use this thing in this case. If I do, x takes the place of t f t cos omega t by 2d. Same thing. I am translated each and everything here. A square is nothing but omega square. And if d stands for differentiation, 1 by d stands for integration. Remember, it is outside the sign, not integral of that. That means you can't place integral here, integrate here. It is better to write it in this way: f t 1 by 2d cos omega t. So that no confusions will come now. Otherwise, you may integrate it here, which is wrong. D stands for differentiation. 1 by d obviously stands for integration. Therefore, I can write if t by 2, then I integrate cos omega t dt. it is sine omega t by omega. Therefore, ft sine omega t divided by 2 omega. Then I write the answer. The answer now is very, very important. Let us see how we can do it, how we can get everything, although we got it very easily. My previous answer was x a sine omega t plus b cos omega t. This is my complementary function. Now this is my particular integral. Therefore both of them are added to get the general solution. But here I am observing one very, very important thing, that I do it slowly so that we can understand what is the meaning of this. I take sine omega t common. If I take, my answer is ft by 2 omega sine omega t plus b cos omega t. I have simply taken ft common, but you see it's a function of time now. I put a plus ft by 2 omega equal to rho cos phi and b equal to rho sin phi. If I put and come here, I get x equal to, this thing is rho sin omega t cos phi plus rho cos omega t sin phi. I can take rho common. I go to class trigonometry. Sin a cos b cos a sin b. That is sin a plus b. In my case, it will be sin omega t plus phi. Now all conjecture starts, and we should do very, very slowly. I can find out the value of omega, rho. I see rho is a function of time. If I find out squaring both of them and understanding that sin square phi plus cos square phi equal to 1, I can at once write rho equal to b square plus a plus ft by 2 omega whole square whole to the power half. Together with the fact that is rho is a function of time now. Therefore, instead of rho simple, which knows that rho is constant, I must write rho t. Now phi, I have divided. If I divide both of them, I can get second by first, tan phi is simply equal to mine b by a plus ft by 2 omega. Wherefrom I can at once get also phi, but note, please note, it is time dependent. Rho here is time dependent and phi also time dependent. Phi is tan inverse b plus a plus ft by 2 omega. We realize that both amplitude and phase are time dependent instead of time independency. This is phi t. Please remember what I told initially. If amplitude is a function of time, it is called amplitude modulation. If omega is a function of time, it is angular frequency modulation. And if phi is a function of time, it is phase modulation. One line summary is simple spring, external forcing, sinusoidal forcing under resonance condition makes both amplitude modulation and phase modulation of communication engineering. This is as such one line summary, which is very important to note, because in communication everything is like that. Whether only omega is very high there 2 giga, 4 giga, 6 giga, very high energy. But main thing is simple this. In this way, whole communication starts. Not your a sin omega t plus rho sin omega t plus phi, where rho and phi are time independent. Such simple thing, but so much engineering applications and engineering understanding. Third, now I come to a very simple case. In the same case, mx double dot plus kx, if there is a resistive force varies as the velocity, that is c x dot equal to 0. C was 0 in your previous case, but if the movement is cx velocity, which I did in our projectile, that resistance varies with velocity. Now resistance in x direction, but same thing. X double dot plus omega square x plus gamma x dot equal to 0, where omega square k by m and gamma c by m. This is just class 12 differential equation. D square plus omega square plus gamma d x here equal to 0. You can solve it very easily, extreme easily. That is m square plus gamma m plus omega square equal to 0. Therefore, m equal to minus b plus minus root of b square minus 4 m square omega square by 2a. Sorry, I did wrong here due to fastness. Minus b plus minus root of b square minus 4ac by 2a. Due to fastness, I did wrong. Please mercy me. Now again, I did not do anything. All cases are with you. If gamma square greater than 4 omega square, two roots are different. Suppose at that time x is a, suppose the roots are alpha 1 and alpha 2, they are distinct. E to the power alpha 1t plus a1 b1 e to the power alpha 2t. If gamma square equal to 4 omega square, extremely important, it is called deadwood case. In galvanometer, my solution should be x equal to c1 plus c2t e to the power alpha t, roots are same, then alpha 1 equal to alpha 2 equal to alpha. Third, most important, if 4 omega square greater than gamma square, then it is alpha plus minus I beta, and you also know how to write the equation, that is your x equal to e to the power alpha t a cos beta t a2 plus b2 sin beta t. And if I draw the diagram, which is the last part, x, this is t versus x, this is the first part, this is the deadwood case, two roots are equal, and last is the oscillatory sinusoidal decreasing, e to the power minus alpha x sine omega t plus theta. Have you ever thought, if alpha is negative, then instead of decreasing in this way, it will be increasing that way? That is the basic thing of oscillator, extremely important thing in electronics and everywhere. In real electron, at that time, alpha is equal to R by 2L NLCS circuit. I can make alpha negative by making R negative. Therefore, negative resistance leads to oscillation. That's all for today. It's a wonderful world. Engineering can give us so much and so many good information that just by observing, I can't understand. Engineers are basically very good thinker. With the hope that will think a lot, I finish this day. Good day.